Good afternoon. Thank you for joining me. So I'm going to talk about the C4 model. This is really a culmination of all of the insights and stories, mistakes, misuses I've seen over the past few years, teaching C4 to well over 200 clients in well over 400 countries, 40 countries, that's a lot of countries. And we're going to get into some bits and pieces about microservices and shared libraries and does C4 scale and notation, all that good stuff. So who's using C4 here? See if I can do this. It's a good chunk of you, but not everybody. Perfect. So I'm going to do a quick recap to what C4 is for those of you who might not be familiar. Architecture diagrams a lot of the time look like this. I think Barry O'Reilly earlier called this the splurge. Nobody wants to use UML for a variety of reasons. Otherwise, we wouldn't be here now. And really, I created C4 as a way to try and bring some structure to those horrible box designs diagrams that most people like creating. C4 is based on 4 simple abstractions. We have software systems, containers, components, and code. So those are the 4 abstractions that sit behind the C4 model. And then based upon this set of 4 abstractions, we can draw some diagrams. So C4 gets its name from the 4 static structure diagrams at 4 levels of abstraction: system context, containers, components, and code. And the concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you do a search for Jersey on something like Google Maps, you're going to get that picture. Now, this is great if you want to know where the airport is and how to get from the airport to your hotel in the town center. It's wonderful. If you've never heard of Jersey because you think it's in the US, this is too much detail too quickly. You've zoomed in too fast. So how do we fix this issue? You pinch to zoom out. If you pinch out a little bit, you can see Jersey sits off the coast of France. Pinch out a little bit further, and it's gone. It's only 9 miles by 5, 15 kilometers by 10. On the flip side, you can keep zooming in, and eventually you'll drop into Google Street View. Now, Google Street View is a one-to-one mapping with the real world when those photos were taken. And essentially, I want to do the same thing with software architecture diagrams. I want different levels of diagrams that allow me to tell different stories to different audiences. The high-level diagrams are great for everybody, irrespective of technical knowledge. As you dive deeper into the hierarchy of abstractions, you get more and more technical detail. So we're able to craft our stories, essentially. If anyone knows Wardley mapping, I know these are not maps, but let's think of these as graphs, if that makes you happier. So I'm going to introduce the top 2 levels of diagrams. The top one's called a system context diagram, and in order to create a system context diagram, that's a set of questions you essentially need to ask and answer. So what's the thing we're describing? What features sit inside? What features sit outside that box? Who's using it? What types of things they're doing? And what are the system-to-system integration points? Answer those questions, and you can draft up a system context diagram. This is an example from a workshop. The red box represents the system that was being designed here. This was drawn during an upfront design exercise. A couple of different users, some features, and the black box at the bottom represents the system dependencies. Pinch to zoom in on that red box, and we can drop down to level 2 and draw a container diagram. A container diagram, it's a different set of questions we're looking to address here. So what are the major technology building blocks? What are their responsibilities, and how do they communicate? Is it API calls, method calls, et cetera, et cetera. And we can draw a container diagram. So now we've zoomed into the red box, and we're showing applications and data stores. So one of the immediate misconceptions here is container in C4 equals Docker. That's not the case. There's an unfortunate clash of naming here. I got the name first, believe it or not. I know that's irrelevant these days because Docker's way bigger, way more popular. But essentially, by container, I'm talking about applications or data stores. So the software systems we build are made up of applications or data stores. Those things I'm calling containers. That's what you can see here. So that's a really nice summary of C4. It's a hierarchical set of abstractions. There are 4 of them. A hierarchical set of diagram types. There are 4 of them. It's notation independent. We're going to come onto that in a second. And it's also tooling independent. Now, one of the things I always say when I'm running my workshops is caveat time. Although C4 has the number 4 in its name, you do not need to use all 4 levels. And honestly, I can't stress this enough because so many people on the internet say C4 is very time-consuming and verbose because you have to create 4 levels of diagram. Nope. You don't have to do that. Why not? Because those bottom levels are very volatile. They take a lot of time to create if you're not automatically generating them, and no one's going to care. Right? You don't want to generate loads and loads of diagrams at the code level because no one's going to ever read them, but they can just look at the code. So this raises an interesting question. If we have 4 levels of diagrams, but people are only using the top 2, 3 levels, why is this called C4 and not C3 plus 1 or C2 plus 2 or some other combination of C and numbers? And the answer is grounding. In other words, a reflection of reality. So George Fairbanks has a great book about software architecture, and in his book he talks about the model code gap, which essentially you have a top-down view of your system, modules, components, services, microservices, whatever it might be, and you have a collection of code. The languages we use today, like Java, for example, Java does not have a component keyword. So how on earth do we make a component in a language like Java? And the answer is naming conventions, annotations, packaging conventions. There's a whole number of ways we can do this. But sometimes that's not evident in the code base. So we talk about having a collection of components, but sometimes we can't see those components in the code. In essence, the top-down view of our system, our mental model of our system, doesn't actually reflect the code. That's why C4 has 4 levels of abstractions, because I'm trying to make sure these abstractions are able to be traceable up and down, and therefore it kind of fixes that model code gap. Notation. Let's start on notation first. I've seen this a lot on the internet. Now, this is my fault, because the example diagrams I've always created to showcase and explain C4 have been a collection of blue and gray boxes. I've never really changed them over the years because why should I? The unfortunate thing here is everybody has seen those blue and gray boxes and they've copied that style. Now this is fine, except if you look at all of the tooling that supports C4, 90% of them also use blue and gray as the standard colors in their standard templates, which is kind of annoying. So you can use any colors you like. I asked ChatGPT what it thought, because I don't have AI in this talk, so I thought this is a good opportunity. So I asked ChatGPT, what color are C4 model architecture diagrams? And it said, drum roll, C4 diagrams don't have a fixed color scheme. That's a win. Hang on a second. What if we do this again? Well, we kind of got the same answer. It says C4 model software architecture diagrams typically use a color palette that emphasizes clarity and simplicity. However, there isn't a strict rule about exact colors. Nice. And then it says, context diagram, light blue or gray. Well, you can't win them all. It does actually say on the C4 website that C4 is notation independent, but a lot of people seem to kind of skip that, unfortunately. Little fun story for you. If you go to the c4model.com website today, you're going to get a set of blue diagrams, green diagrams, or red diagrams. If you go back tomorrow, you'll get a different color. So I've done this on purpose because it kind of gets rid of this C4 is just blue and gray boxes. So that's gone now. We can kind of squash that myth. You could also, I know this might be controversial, you could also use UML as your notation. So I know that no one really wants to use UML these days, but imagine a world in which UML became something again. You could use UML as your notation for C4 model diagrams. Why? Because C4 is really only 2 things. It's a set of abstractions and a set of diagram types. UML doesn't give you those 2 characteristics, so you can combine these things, and they're somewhat complementary. Viewpoints. I've had a few people say that C4 is not good at showing decisions, which is the correct answer. It's not supposed to. The architecture diagrams we draw show the outcome of the decision-making process. They shouldn't show all of these decisions because it would clutter the diagrams hugely. So that raises the question, well, where do we store decisions? And the answer is ADRs. Right, this is not hard. This has been spoken about a million times. But lightweight documentation, set of ADRs and a set of diagrams, hopefully some traceability between the 2, and we're all good. I've had people say that C4 kind of ignores the runtime story and it only focuses on the static structure diagrams. Again, I think this is partially my fault because when I introduced C4, I introduced the static structure diagrams first. C4 is named after the static structure diagrams, so I can see where this comes from. If you go to the C4 website, there's actually a bunch of supplementary diagrams that are described on there as well. You can draw sequence diagrams. So a UML sequence diagram is probably the one thing that has survived the UML backlash. Sequence diagrams are super useful. In a typical sequence diagram, you're showing objects, so instances of classes typically interacting in runtime. There's nothing stopping you showing instances of C4 abstractions and how they are put together at runtime. You can also use a UML collaboration style approach where you've got a free format diagram with numbered ordered arrows. Follow the numbers, go up in order. That's another way you can talk about the runtime story. The reason I don't talk about these too much is because I kind of use them very sparingly. If you're building a web app and it's got 100 features, please don't draw 100 of these diagrams, one per feature. That's way too much for anybody to kind of look after. So I only use these diagrams sparingly to show complicated sets of interactions, or where it's just easy to show a repeating recurring pattern, for example. Similarly with the deployment story. Again, if you go on the website, there is a deployment diagram. UML has a deployment diagram, 4+1, and C4 was inspired by all this stuff. It has a deployment view. And so I've taken that same thing, and really I'm just reshaping 4+1 is another way to think about this. So if you go onto the C4 website, there's a bunch of example deployment diagrams. And what I'm showing here is the mapping of C4 container instances onto infrastructure. I'm going to call those things deployment nodes, or potentially instances of entire software systems. So we can use abstraction to our advantage here. And sure, you can do cloud architecture diagrams as well. So there's nothing preventing you taking your cloud icon packs, AWS, GCP, Azure, using the nice icons and the colors to craft up some cloud architecture diagrams, essentially showing you how C4 instance, container instances from the C4 model map onto things in the cloud environment. That's absolutely fine as well. This is an interesting one. What about all of the other stuff that might be harder to show on diagrams? You know, security, failover, ownership. Often putting all of this on a single diagram makes your single diagram become quite cluttered. As with all of this diagramming stuff, you have a number of ways to think about and optimize this. It depends what story you're trying to tell and who you're trying to tell it to, for example. But another way to do this is to take the perspectives approach from Owen Woods and Nick Rosansky's book, Software Systems Architecture. So perspectives is not creating a new view type, it's taking your existing view types, so the diagrams I've already shown you, the static structure diagrams, the runtime diagram, and the deployment diagram, and a perspective is really just a layer on top of that existing diagram. So what you could do is you could draft up your static structure diagram showing containers, showing applications and data stores and how they interact at runtime. And then you could have a security layer that says this is how security is handled in all the boxes and how security is handled in the communication between the boxes, for example. If you're using Visio, you might have to do this with layering. My tooling Structurizr will kind of support this out of the box. Okay, so this section was initially titled C4 versus DDD, but I thought that might be a bit controversial, so I changed it. Because I have to leave this room afterwards. I've had a bunch of people say this to me, we don't need C4 because we do DDD instead. I'm like, well, please explain more. And I think they have a misconception here about C4. From my perspective, C4 is just a way to draw some pictures at different levels of abstraction. That's it. So it's a diagramming approach. It's not a design process. Now, something I've seen people do, please don't do this. Hopefully I can trust you not to do this. But if we go back to my intro to C4, some organizations will take the context diagram and ask the product owners to draw that because they're non-technical. And then they hand that to a set of architects to draw the container diagram. And they hand that to a set of developers who can then draw the component diagrams. So they're treating each level of diagram as a separate step in a waterfall style process. Please don't do that. This is just a set of diagrams. You can draw these diagrams however you want to. For design, for long-lived documentation, there's no design process here. If you're doing ports and adapters, your component diagram should show ports and adapters. If you're doing components and layers, your component diagram shows you components and layers. There's nothing in C4 that should be influencing the design choices and decisions you're making, essentially. And therefore, this complements all the other things you have in DDD. Event storming, context mapping, domain storytelling. You could essentially do domain storytelling as those dynamic sequence style diagrams with more icons and kind of more narrative if you really want to. So there's nothing in C4 that's really competing against DDD here. Events and messages. Somebody told me that C4 doesn't support event-driven architectures. And I'm like, what? Like, can you point me to the thing that says that? And they weren't able to. And they just said, well, all of your example diagrams show dependencies. And we don't want to show dependencies, we want to show events. So my response was, we'll draw that. Stick a line in the middle with event, and we're done. So there's fundamentally nothing here that prevents you using C4 style diagrams for event-driven architectures. You just have to make sure you figure out what the arrow should represent, and you make sure the text on the arrow represents the events rather than dependencies. So what about C4 not suiting event-driven and message-driven architectures? This is a little bit more of a more general point. And I've seen this pop up a few times, and it normally pops up because people try to draw their message-driven architectures like that. So imagine you have a service-based architecture. You've got a bunch of services on the left-hand side producing messages, and those are being forwarded to a bunch of services on the right-hand side. What they've tried to do here, and I see this a lot, this is a common misconception, they've tried to treat the message bus, so Kafka, RabbitMQ, for example, as a C4 container. And that's where they've gone wrong. So that raises the question, well, how should we do this? What I tend to do is I tend to recommend modeling the queues and the topics as C4 containers. So a C4 container is either an application or a data store. A queue or a topic is essentially a data store, isn't it? It's a bucket. Some processes over here put messages into the bucket, and processes over here pull messages out of the bucket. This doesn't tell you anything about the deployment. So those two queues, X and Y, could be running and hosted on a single RabbitMQ or Kafka cluster. Or, if they're super, super high traffic, and maybe owned by different teams, QX could be on its own cluster, and QY could be on its own cluster. So again, this doesn't tell you anything about the deployment. So in this example, we have all the arrows going from the left to the right, sends message to, sends message to. If you have a genuine one-to-one point-to-point coupling, which many people do in their systems, even if they're using events and messages, you could rightly argue that that queue in the middle just adds visual noise. It doesn't really add much value. And I agree, it's all options, so you could do that instead. So here we've wired up the services together directly, and on the arrow we've said via QX. So this is still showing the same information in a much more condensed, succinct visual format. The trade-off here, and this is all trade-offs of course, the trade-off here is that someone glancing at this diagram might not understand that there's a queue or topic as an intermediary between those services. So you have to figure out which of these diagrams do we like the best. You can also experiment with switching arrows around as well. So in this example and the previous example, the arrow goes from the left to the right, sends messages to. You can also do this and have the service on the left-hand side publish into the queue or topic, and things on the right-hand side subscribing to. So we flipped the arrows around. You might find this works better for some people when they're having a conversation, and they use words like subscribe and publish. And you might also find this works better for one-to-many style interactions and relationships. So you have a collection of options, essentially. There's never a single perfect right answer here. C4 is too limiting. This is a big topic, and it stems from the fact that C4 defines 4 abstractions. And all of my example diagrams are relatively small, and they have like 6 boxes. And when people try C4, maybe for the first time on their huge big monolith, they realize it's hard because they've got tons of boxes. And therefore, this is too limiting, C4 doesn't scale. But before they get to that point, it turns out they have some issues trying to figure out exactly what things should be represented as what things in C4. And I saw this blog post a couple of years ago. The problem is that systems today have many different kinds of things. Servers, databases, virtualized containers, APIs, pipelines, repositories, you can read the rest. Forcing them into one of C4's 4 levels of abstraction doesn't really accomplish much. So this is, well, we have tons of things that we're working with. Why should we cram them into 4 levels of abstraction? That doesn't seem like a worthwhile use of our time, essentially. And this quote also came from that same blog post. A database is a database. Debating whether it is also a container or a component just is not worthwhile. And I completely disagree. The whole purpose of this is to become more structured in how we think about architecture and therefore how we draw architecture diagrams. And we can only do that if we really understand the words that we're using. Now, some of you might be thinking, well, yeah, a database, just a database, who cares? But what do we mean by database? Is this a database server or a database schema? Is it just a collection of data? You know, what semantics are we also attaching to that word? And that's going to vary depending on our knowledge and experience. You know, a software developer might have a very different view from an infrastructure person. The software developer is talking about collections of tables, for example. The database administrator or the infrastructure person who's running database servers might have a very different view of the world. So we have to make sure our worlds align. Let's put this in context. You'll see a lot of people say this: microservices should not share a database. Right, seems like a reasonable piece of advice, but it depends. So if you have 2 services owned by different teams, I'm happy for those 2 teams to share a single database server for reasons around operational ease, maybe licensing costs, server resources. There's a whole number of good reasons why multiple services can share the same database server. I don't want them putting data in the same database schema, so in different tables in the same database schema, because then it's very easy within a single, say, MySQL schema, it's very easy to start joining across tables owned by different services. That's bad. So again, we have to figure out what do we mean by the word database to figure out if this is good or bad advice. What I'm trying to do here is make our terminology more precise. We throw words around a ton in the industry, and we're often not being precise. And one of the reasons I like this, you know, we're trying to draw a diagram, is this thing we're trying to draw a C4 container or a component. It forces us to map it onto those abstractions and have some interesting real-world discussions. So from my perspective, and this sounds a bit weird to say, the true power and value of C4 is actually not from the diagrams. The diagrams are like a super useful output and artifact. But the real power of C4 is that limited set of abstractions to sit behind the scenes. It gives us a small set of words that we can use to reason about the systems we're building. And you can see this. If you go and search around for people who are doing architecture, capability, maturity, and improvement exercises, so for example, this one from Decathlon on InfoQ that was published a little while ago, they're using C4, and it says it requires teams to address and synchronize their mental models of the code components, containers, and even the context of applications. So this shared language is not a shared visual language. We're creating a shared non-visual language, and we're allowing teams to use that in order to draw their diagrams. I'm going to talk about tooling a little bit here. I'm going to come back to tooling later. So I have my own tooling called Structurizr, which is a bunch of Java-based tooling. It's all open source. It's all free. You can find it on GitHub. And there's also something called the Structurizr DSL, which gives you, I think, a nice text-based DSL in order to model C4-style architectures. Some people find that too limiting, and there's another tool that came out a couple of years ago called Like C4. And this is kind of how it's framed, inspired by C4 and the Structurizr DSL, but with some more flexibility. You define your own notation, so you can define your own notation in my tooling as well, and any number of nested levels in the architecture model. So this is the key difference here. With my Structurizr tooling, you're stuck with software systems, containers, and components. It doesn't support level 4. This like C4 tooling allows you to create any number of arbitrary levels of nested abstractions, which on the face of it sounds pretty cool. Because now you can throw your real-world things into any number of nested abstractions, and you can perfectly tailor your model and your diagrams. The problem is this. If you go to the web page for like C4, they say, yeah, you can define your own nested levels of abstraction, and it gives you this as an example. So here we've got a model comprised of a service. That service has a backend 1 and a backend 2. These are both components. And then inside the backends, there are more components nested at the next level down. So now we're back to this whole, like, what is a component question? UML has its own definition. The dictionary has its own definition, part of something bigger. But this is the problem I created C4 to try and avoid and try and solve in the first place. If we're going to have multiple levels of abstraction, let's be a bit more precise and just not use the same word for all of them, essentially. You could nest these as much as you want as well. Like, please don't do this. So this is why I'm not a big fan of being able to allow teams to craft up their own arbitrary levels of abstraction. So let's step back for a second. What have we done here? If we look at the ad hoc, horrible splurge diagrams that people typically draw, they're just ad hoc random boxes and arrows with no semantics, no well-defined notation. C4 comes along, and what I'm doing here is I'm trying to add some structure around the diagrams. I'm introducing some set abstractions, and there's a bunch of notational guidelines you'll see on the C4 website. But some people think that's limiting, and they want to go a step further and define their own flexible hierarchies of abstractions. And they see this as a progression from C4. The problem is, it's not. Because if defining levels of abstraction was easy, we would never get to this situation down here. So this is not a like a linear continuum, it's a circle. And the problem here, of course, is allowing teams to define their own arbitrary abstractions. It's hard, so they mess it up, and they eventually get back to ambiguity, vagueness, and we're back to square one again. So that's one of the reasons I don't recommend teams start introducing lots of levels of hierarchy and more nested abstractions unless they really, really want to. For me, that's an advanced maneuver. So how do you model bigger things? What if we want to add more abstractions? It's an interesting question. It is an advanced technique, and if you really have a good need to, and you are perfectly capable of defining those abstractions clearly and cleanly, go for it. But for most people, I don't really advise it because it's kind of hard. So what are my thoughts on modeling different additional levels of abstraction? Take layers. So imagine you want to draw layers. You want to draw like a layered architecture diagram. I'm sure we've all done this before. I certainly have. Imagine we have some web application, and it has a controller layer, a service layer, a repository layer. Is this a useful diagram to draw? Not really. I've done this. It's useful for showing architectural principles, but I don't think this is a good architecture diagram because I don't really see those layers as being abstractions in their own right. You can't just like rip them out and replace them with something else. So from my perspective, these layers are really just groupings. They're organizational constructs of the things that exist inside them. In other words, imagine we have a bunch of services. These are components, and they sit in the service layer. I think the service layer is just a grouping of those components. And that's how I'd rather represent a layer. A layer for me is just a grouping, a boundary around the things that sit inside the layer. So here we have a service layer and a repository layer. If you want to start showing things like module boundaries or build time module boundaries, you could do that. So you can say that these services come from the app service.jar file. So you have a number of ways to supplement and superimpose more information on the kind of key C4 diagrams, essentially. You can also apply this concept to subsystems. So if you want to model things like subsystems in your software architecture diagrams, you can do. And also things like bounded context. I get a lot of questions about how do we show DDD bounded context on architecture diagrams? And the answer is just take the same approach. If you have a really nice, neat, ideal situation where, in this case, systems A and B neatly sit in a single bounded context called 1, and system C neatly sits in its own bound context, then you can just draw that grouping around those boxes. In the real world, I get that bounded contexts might dissect through some of these software systems, but maybe you can see that at the next level down, for example. Shared libraries, same deal. A lot of people want to model shared code, shared libraries, and they'll do it like this. They'll try to model the shared library or shared code as a C4 container. This is generally not correct because C4 containers are applications. They're individually runnable, deployable things. The logging component is not a individually runnable thing. So this is a better option. Show the logging component as being included in both applications. This is essentially what your build process does. You declare a dependency inside two applications. Your build process pulls that code down and embeds it into your ultimately deployable artifact. You could add the organizational boundary to say this logging component comes from a shared library.jar file. You can start adding version numbers if you want to. So you have a whole number of other different options to start better showing things like shared code, for example. Microservices. Oh my goodness, this has caused a lot of confusion over the years. This is essentially written in a book. I'm not going to tell you who wrote it. I disagree. There's nothing in C4 that makes it unsuitable for distributed architectures. I think the underlying problem is really one of scale. In other words, the author doesn't think C4 scales, but I'm going to also answer that misconception shortly. So how do you model microservices with C4? It depends, right? Which is a wonderful thing to say, but here are your three options. It's either a software system, a container, or a grouping of containers. Now, the best way to work through these examples is to run through a scenario, and then we can see all the examples one by one. So imagine we're a startup, we have no money, and we want to build something. The first version of our thing arguably should be a monolith, because it's quick to build, quick to deploy, and we don't have to focus on operational concerns and distributed tracing and monitoring and server provisioning and all that good stuff we get in microservices. So we're going to start simple to build a monolith. So imagine we are building a software system called X. I know, unfortunate name, not that one, our X. We're building a software system called X. It has features A, B, and C, and we have some type of user. So that's my system context diagram, nice and simple, nice and straightforward. When we do the pinch to zoom in, we're going to build a server-side rendered monolithic UI. So that's the web app box. It's a Java and Spring MVC server-side application implementing the UI and the business logic. And we're going to stick all data in a single monolithic database schema. That's going to be MySQL. All good? Nice. So that's stage one of our startup's journey. No microservices quite yet. After a few years, we hire some more people, and the code starts getting in the way. You know, we have all the code in one place. We've got more people doing merge requests and pull requests and stepping on each other's toes, and it's starting to slow us down. So we want to start breaking the monolith apart, and we want to go to something more kind of microservices based. In order to answer this, we have to go through the, well, what the hell is a microservice anyway question. I'm going to answer this very simply by going back to the Martin Fowler, James Lewis definition, which is the kind of canonical definition. They say, in short, the microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. We all know that. I like this. I'm going to use this definition, but I'm going to change one word because I want to bring this into C4 land. The word I'm going to change is application. So I'm going to say that the microservice architecture style is an approach to developing a single C4 software system as a collection of small services, each running its own process. So our context diagram stays the same. We are still one big team. We're still building that one big system. Inside the system, we don't have a monolith anymore. We have a set of services. So because I don't want to get into the complexities of micro front ends, we're going to keep the good old-fashioned monolithic server-based UI. And we're going to split all of the business logic and the data out into individual API things and database schema things. So we have one service for A, one service for B, one service for C. Each service is an API thing and a database schema thing. And I've used color coding here to kind of join these two things together from a visual perspective. Now, we can't see the services. Right? The service is a pair of elements here. We can't see those services. So how do we fix that issue? We just use the advice I gave you before. We just draw a box around it. So now we can see that service A is the combination of the API thing for A and the database schema for A. Repeat for B, repeat for C. So that's one of our options ticked off. A microservice here is a grouping, in this case a pair, it's a grouping of containers. Imagine we want to add feature D to our system. Feature D is going to be implemented by a single AWS Lambda written in Python. There's no data, it's completely stateless. Well, now we have our second option ticked off. Service D is a group of containers, but that number is 1, so therefore the service is also just the container. So that's generally my approach to showing a microservices style architecture. Remember, we're all one big team. We can all change any of these services as we want to, but all of these services live inside that single software system boundary because we're still one big team. You'll often see a link between a software system in C4 and a development team who's looking after it. So now imagine we've gone to some venture capitalists, we've got bricks of cash being held at us, and now we want to go really fast and scale more rapidly. Now we can hire more people, and we want to maybe start adopting Conway's law. We want to maybe change our organizational structure to match our architecture. We need to change our architecture. So imagine I'm going to say with the original team, I'm going to build software system X, and all you lovely folks are going to disappear into teams looking after service A, B, C, and D. So now we have 5 teams in the organization. I'm on team X, building software system X. This is my my context diagram. It shows the system I'm building, and I have a dependency on the systems you are building. So what I've done now is I've ticked off the third option. I'm treating all of these services as software systems. Why? Because I can see my world, I can see the internals of my world, I can't see the internals of your world. You've taken your code, you've put it in different Git repos, there's a team boundary between us now, we're completely autonomous. We've adopted Conway's law. You own your own services. There's nothing to do with me. I can't see details. I'm treating those as essentially black boxes I can't see inside of. My container diagram basically looks exactly the same. It's a server-side rendered web app with dependencies on your software systems. From your perspective, if you folks over here are team A looking after software system A, service A, that's your context diagram. So you're focusing on service A, and you have an inbound dependency from my software system called X. When we drill into your software system boundary, your container diagram looks like this. It shows the API thing and the database schema thing from before. So again, you're showing your implementation details, you're not showing mine, so you can't see my server-side rendered web app. And that's generally the approach I take with modeling microservices and also modeling things between teams. Now, some of you might be thinking, well, what if I want to show both sides of that equation? What if I want to show that a container in this system talks to a specific container in this other system? So in other words, what about drawing that picture? You could do. If you have the data to support this, there's nothing stopping you drawing this diagram, showing all of the container-to-container links across software system boundaries. However, it's a form of coupling. If I own this diagram, it shows that I know how all of your services work at some level of implementation detail. If one of you decides to break your API into 2 API things, well, my diagram is now out of date. You have to now tell me so I can fix that. So it's an interesting form of coupling. There's a degree of volatility there. When clients ask me this question, one of the flags that kind of raises in my head is this organization really a number of separate teams, or are they just one team pretending to be multiple teams? So sometimes going through this exercise can bring up some interesting challenges and conflicts and tensions between teams and how they're organized. So I don't recommend it. It's a form of coupling, volatility, et cetera, As with always, there are some exceptions. Imagine you've got 2 systems and they're integrating via a shared database schema. I know we're not supposed to do that anymore. but it happens, especially in large organizations. You might want to show that that shared database schema is a C4 container, and it kind of sits in between our two systems, maybe owned by a fake third system. So, take all these things with a pinch of salt. You might have to work around some of them. Tooling. I'm going to talk about tooling very, very briefly, just to kind of wrap up, because there are a number of other C4 misconceptions and mistakes that I think are actually attributed to tooling. And I think the C4 does not support microservices architectures is potentially one of those. So one of the things I see here is, well, C4 doesn't scale. And it's not that C4 doesn't scale, because I've shown you a bunch of different options and approaches on how to do that, but really it's the tooling that teams are using. If you're using something like Microsoft Visio or Draw.io or Lucidchart, you have to copy and paste boxes across multiple canvases to try and make your diagrams understandable. But really, that's the wrong sort of tool to be using for this. So I'm going to show you a very super quick demo with my Structurizr tooling. What I have here is a Structurizr workspace DSL file. So this is my Structurizr DSL. And what I have here is a software system comprised of 8 microservices. So here is the definition of Service 8. Service 8 is a microservice comprised of an API thing and a data store thing. If any of you are thinking, well, how is he doing this? I'm using Structurizr. Is this a new feature? Yeah, this is a new feature called archetypes. It allows you to alias some of the core C4 concepts. So we have 8 services, all comprised of an API thing and a data store thing, and we have a bunch of relationships between them. So that is going to result in a diagram that looks kind of like this. So here's our container diagram for this particular example. We have a user. They are requesting the UI from this kind of web server, Nginx in this case. That delivers the UI, the JavaScript UI, to the client. The user then uses the UI. And the UI itself has a bunch of links to services. So maybe these are kind of like RESTful JSON over HTTPS type API endpoints. So here we have 8 services. Every service is a pair of different elements here. Now this diagram kind of works. But as we add more services and more inter-service relationships, you can see how this could start to get quite complicated. And this might lead to people saying, well, C4 doesn't really scale because our diagram is just enough to mess. Hence, we need to add more levels of abstraction. So rather than drawing one diagram showing 8 services, what you can do instead, and this is why tooling is important, is you could draw one diagram per service. So this is still a C4 container diagram. It's still showing you containers inside that software system boundary. But here we're showing service 1, things coming into service 1, in this case the UI, and things coming out of service 1. So the inbound and the outbound dependencies, the afferent and the efferent couplings, if you want to think about it that way. Then we can have another diagram focusing on service 2, things coming into service 2 and things leaving service 2, and basically repeat for services 2, 3, 4, 5, 6, etc. So how do we do that? Well, with a tool like Visio, that's an absolute nightmare. With the Structurizr tooling, because it's building a model behind the scenes, you have a data set here that you can play with. It's reasonably easy to slice and dice the model. So this is the Structurizr DSL that gives you all containers inside the software system boundary, include star, that's what that does. This is the service 1 version. It says include service 1 in the software system A boundary, and also magically include anything coming into it and anything going out of it at the container level. So we can use this powerful expression language to slice and dice the model and therefore create different views, which allows us to scale this whole thing. The downside of this approach, of course, and it is all trade-offs, I can't stress that enough. Here we can see everything, but the diagram becomes complicated. Here we have a number of simpler diagrams, but we can't see everything. It's all trade-offs. So you have some options. If I go back here and in my tooling go to this button, we get this really cool D3JS force-directed graph. This is why I wanted to come and show you on my laptop, because it's interactive. The screenshots don't do this justice. So we're still showing C4 containers here, but we're using a much more condensed, less verbose visualization format. This has a quick find feature, so we can say, give me a list of all the things that have a connection directly to or from the UI. There are tooltips on here. We can show nearest neighbor. So this is a better way to explore a larger data set. This could be systems in a landscape, containers in a software system, as we see here, or components in a monolith. I'm going to give you a third option, which is to take this data set. My Structurizr CLI tool allows you to export to various formats, including plant, UML, and mermaid. It also supports the Ilograph format. And here is an example I prepared earlier. This is the same data set in the Ilograph tool, not mine, but it's a cool tool. And it's basically giving you another visualization on that same data set. And it's also interactive. We can click around, show nearest neighbors. So it depends really what you're trying to do here. Are you trying to explain how the system works? Or are you trying to answer a question like, what happens if we change this thing called X? I was talking to someone at the conference this morning. Feel free to raise your hand and wave your hand if you want to be identified. If not, that's fine. They're using Structurizr. They've taken the Structurizr model, flattened it, loaded it into an LLM, and they have a bot. And now they can do queries. Show me the owner of system X. Like, how cool is that? Once you get away from using Visio and Lucidchart and Draw.io and Plant, UML, and Mermaid, and you get back into modeling again, you have a data set, and there's a bunch of cool stuff that you can do on top of this data set, essentially. So that's one of the reasons, or that's one of the ways I would kind of attack the C4 doesn't scale thing. But we still have this issue. C4 doesn't solve the problem of diagrams become out of date. It doesn't. It was not designed to. It's just an approach to diagramming architecture at different levels of abstraction. But again, tooling can either help or hinder you here. If you're using Visio, you're stuck. If you're using something like my Structurizr tooling, other tools are out there as well, there's a bunch on the C4 website, you can automate some of these diagrams. So for example, the system landscape and context diagrams, how might you automate those? Well, if you have a service registry, Backstage, ServiceNow, you can write some code, put all the information out, all the services and systems and relationships, and then visualize that. You could pop it into my Structurizr format if you want to. The container diagrams, you could do the same thing. You could also parse log files. You can use things like OpenTelemetry. Chris Simon said this morning, if you name your API endpoints after your domain concepts, you have a really nice way to maybe generate a really nice looking diagram. Component diagrams. So now we're in the code. We want to visualize the components that sit inside an application. It's all the good old-fashioned techniques around static analysis and reflection and reverse engineering and parsing code to figure out what the components are, what the component boundaries are, and what the relationships are between those things that exist in our code base. This is reasonably straightforward to do for OO languages, particularly things like Java and C#, but there's very little tooling out there that does this usefully. If you reverse engineer code, you generally get a massive mess of class diagrams that's not particularly useful. What I want to do here is kind of leverage C4 and say, right, let's identify the collections of code elements that come together at runtime to form a single component, and let's draw that thing as a single box on the diagram. So again, I have some tooling that does this. This is recently released this year. In my Structurizr DSL, you can basically say, yeah, I want to go find components inside this compiled Java application. And you can plug in different strategies for finding those things. So here we're finding the Spring MVC controllers, and we're finding the Spring data repositories through a bunch of pluggable rules. That little block of code will automatically generate this component diagram. We can pull descriptions from source code from the Java comments. The relationships are the intercomponent dependencies. We can double-click on a box here to take us to the page on GitHub. There's a bunch of useful stuff you can do once you get past the kind of, I'm just using Visio. And deployment diagrams, same thing. I don't have any tooling to do this myself, but you could parse Terraform and CloudFormation descriptions to reverse engineer yourself a deployment diagram. You could pull down your AWS config and do the same thing. So you have a number of options here to keep your diagrams up to date, to prevent that model drift, but you need to put some effort into doing this, and that's where the hard part of this sits, of course. So a final note. I've been working with C4 for like 15 years. I've been teaching it to hundreds of people around the world. And I've been trying to take my clients through a journey to try and get them better at software architecture diagramming. And I've come up with this kind of fairly straightforward architecture diagramming maturity model. Level 1 is where I would guess 40% of the industry sits. They're doing nothing for a number of reasons we don't have time to get into. Level 2 is the splurge. It's all those horrible-looking diagrams. That's where I think, again, 40% of the industry currently sits. Learning and using C4 gets you to level 3. It gives you a set of abstractions to work with, and it gives you some structure. And you can do that with any tooling. Levels 4, now we're switching from diagramming to modeling. We're not having to repeat elements across diagrams. We're trying to create a central dictionary of things and have those popped up on all our diagrams. And level 4 is really where we're starting to optimize this whole process. We're looking to automatically generate diagrams from artifacts from source code. We're looking to share models across organizations. We're looking to automatically generate landscape diagrams from a collection of decentralized C4 models owned by different teams and stored in different repos. You can do that once you get past the we're just using Visio, for example. So that's your summary of C4, set of abstractions, set of diagram types, notation independent, and also tooling independent. Thank you very much. Take care.